subscribe, and share.
Hello, welcome to Biochemistry Simplified. My name is Dr. Elik, and today we'll be looking at the fate of pyruvates. We'll be looking at what happens when pyruvate is formed through the glycolysis or glycolytic pathway. We have looked at the glycolytic reactive steps in details, and we now want to look at the pyruvate that is formed, what happens to it, the fate of pyruvate. So we'll just quickly look through this. Is for glucose. Normally glucose, from glucose we are able to get through the glycolytic pathway to pyruvate in a 10-step reactive step. So glucose from glycolysis here, glucose from glycolysis, then glucose goes through the glycolytic pathway and produces two molecules of pyruvate like we have established. So when two molecules of pyruvate is produced, what happens to it? Pyruvate can go through either pathways, through and in the presence of oxygen, excess oxygen, or plenty oxygen. We name that aerobic condition. When oxygen is present, oxygen present here, when oxygen is present here, aerobic condition, pyruvate is converted to two molecules of acetyl-CoA. Pyruvate is converted to two molecules of acetyl-CoA, and the acetyl-CoA can go through oxidative phosphorylation and also go through the citric acid pathway. So it can go through either of these pathways, oxidative phosphorylation. It can go through the electron transport chain and also go through the citric acid pathway, and the product, what is produced is carbon 4 oxide and water. That is going through the presence of oxygen right here. Oxygen is present. Okay, let me just do this. Oxygen present plus for present. Okay, so oxygen is present there, and pyruvate goes through aerobic condition and produces two molecules of acetyl-CoA, and also produces go through the oxidative phosphorylation and also the electron transport chain, and also goes through the citric acid cycle pathway and produces carbon 4 oxide and water. The pyruvate can also go through the anaerobic condition. In going through the anaerobic condition, it produces what is called lactate, two molecules of lactate. Anaerobic condition simply means no oxygen or not enough oxygen. So this is a condition where you have no oxygen no oxygen, no oxygen. I need to get my pen. So no oxygen or not enough oxygen at the anaerobic condition, and what that produces is two molecules of lactate. Two molecules of lactate. So lactate is what you feel in your muscle, what you feel when your muscle starts to get sore from overexertion. This is what splinters or razors feel at the field. The muscles are not getting enough oxygen to burn aerobically, so they have to form and go through another process and turn to another process, which is the anaerobically uh, producing two molecules of lactate. Lactate is a byproduct of that process, of that anaerobic process, whereby two molecules of uh, lactate is formed, and lactate, that process builds up lactate, and this is when what you feel when your muscles begin to ache. It happens in the presence of no oxygen or not enough oxygen. Then you have another process, is still the anaerobic process or the hypoxic process. And in this process, what you have is low oxygen, low oxygen. There's oxygen, but it's very low. So you have low oxygen as opposed to no oxygen. So we have low oxygen here, low oxygen as opposed to no oxygen. So it is called the aerobic or hypoxic condition. What that produces is two molecules of ethanol plus two molecules of carbon 4 oxide. And this is where we get our drinking alcohol from, through the anaerobic or hypoxic process, in the process of low oxygen as opposed to no oxygen. Alright, so basically that is the fate of pyruvate. That is the different pathways in which pyruvate can possibly go through. So we start from glucose in the glycolytic process, and glucose here produces um, two molecules of pyruvate through the glycolytic pathway, and when that is produced, what you have is two pyruvate. Now, how the pyruvate goes is in the presence of oxygen, plenty of oxygen, you pyruvate is converted to two molecules of acetyl-CoA. The two molecules of acetyl-CoA can go through oxidative phosphorylation and subsequently through the electron transport chain, and it can also go through the citric acid cycle, and what you have as final product here is your carbon 4 oxide and water. Pyruvate again can go through the anaerobic process. What that means is that anaerobic condition means no enough oxygen or no oxygen at all, and what it produces is two molecules of lactate. Lactate is a byproduct that is formed in as a result of fermentation in heavily worked muscles. As a result of fermentation in heavily worked muscles, and this is what you feel when your muscles start to get sore from overexertion. Example is for you see this in razors and splinters, and you also not get enough oxygen, and as a result, because the muscles is not getting enough oxygen, it turns to burn, from burning aerobically to anaerobic process, and the byproduct is lactate. So what is fermentation generally? Since lactate is formed from fermentation of heavily worked muscles, fermentation in the general term is the breakdown of organic molecules under low oxygen or no oxygen conditions. So you also have the next step in which pyruvates can form in anaerobically or hypoxic condition. That's the presence of low oxygen as opposed to no oxygen at all. And what that forms is two molecules of ethanol and two molecules of carbon dioxide. This is what we get from drinking alcohol. In our next lesson, we'll begin to look at the overall reaction steps and the formation of energy. How much of energy is formed from the overall reaction of glycolysis.